Chapter 8, What About Us? Raymond Dart was a famous anthropologist and anatomist, best known for his involvement in the discovery of the first fossil ever found of the Australopithecus africanus, an extinct hominid closely related to humans. He had spread the word that he was looking for interesting new finds to stock his new anatomy museum. Lucky for him, he was sent a box of bones. When he received this box of bones, he opened it immediately and was drawn to what looked like the interior of a skull. At a closer glance, he noticed that the skull was not big enough for a primitive man, but it was too big for an ape. Though further examination, he could see that this was actually the skull of a child. And then he thought to himself, could this be the possible missing link between modern humans and ancient ancestors? He immediately thought of Darwin and his theory that early man started in Africa. Although this was truly a phenomenal find, not everybody believed it to be true. Human evolution was and still is a pretty tough subject. Many creationalists do not believe in human evolution. They believe in divine creation of humans. During his time, Charles Darwin was truly a pioneer when he asserted in his book, The Descent of a Man, that not only had humans evolved from ape-like creatures, but they did so in Africa. And this was not something that many people wanted to hear. Even Charles Darwin had a tough time convincing his colleagues. Even though fossil records were pretty sparse during the 1800s, we were able to find our place on the evolutionary tree. Linnaeus proposed that our anatomy placed us in the order of primates along with monkeys, apes, and lemurs, all sharing traits such as forward-facing eyes, fingernails, color vision, and opposable thumbs. More specifically, we belong to the hominid family of greater apes, such as chimpanzees, gorillas, and orangutans. Through DNA and protein sequencing, we confirmed that we are closely related to chimpanzees, and we share about 98.5% of our DNA with them. We also know that we diverged from our joint common ancestor about 7 million years ago. So now knowing this information, what traits can we expect to see in an ancestral fossil? Well, for one, we should expect to find shared traits of chimpanzees, gorillas, orangutans, and even some human traits. We should also expect to see brains getting relatively larger and posture becoming more erect as fossils become more recent. Unfortunately for us, we don't have a continuous lineage. Instead, we have a tangled bush of many species, some dead ends with no descendants, and the problem being we have too few species to confidently draw any conclusions about our lineage. So if we suspect we found a new species, we can't really decide if it's actually a new species or if it's just a variation of something that we've already found. There's just not enough information for us to go off. So how can we determine patterns of human evolution? Well, first, we have to remember that we diverged from chimpanzees about 7 million years ago. So anything older than that wouldn't really count as human evolution. Also, we can look at postures. Humans have more of an erect posture, something that our ancestors didn't really have. Another thing is being fully bipedal. This is very specific to humans. So when we look at the knees, specifically the femur, we can see the way it's connected to the pelvis and the way it's connected to the knee. If the femurs angle in towards each other, then this promotes bipedal walking. And the last thing I want to mention is tool making and tool use. And although chimpanzees can use simple tools, more elaborate tools will probably require more flexibility of the thumbs and an erect posture that'll free the hands.
Homo erectus, otherwise known as the upright man, is the first hominin to leave Africa. It has characteristics that support human evolution, such as brain size, which is the same size as modern humans, the use of complex tools, its skeletal structure, and it made history for being one of the first species responsible for controlling fire. Because of its longevity, it also has two possible descendants, Homo heidelbergensis and Homo neanderthalis, otherwise known as the Neanderthal man. The disappearance of Homo erectus may be related to Homo sapiens. There are two possible theories that explain their disappearance. The first is multi-regional theory, which proposes evolutionary replacement. Homo erectus evolved to Homo sapiens independently in many areas. The other theory would be out of Africa theory. The modern Homo sapiens species originated in Africa and spread physically, replacing Homo erectus and the Neanderthals by outcompeting for food or harming them. There is more evidence that supports this theory more so than the multi-regional theory. A critical period of hominin evolution would be 3 to 10 million years ago when Africa was in a drought. It was a drier land and it alternated patterns of drought and rainfall. A change in climate is believed to have driven the first significant hominin trait to evolve into bipedalism. This could be explained by the species wanting to free their hands to collect more food or to deal with body temperature when it's too high by raising the body off the ground to decrease the surface area for the sun to hit. Additionally, the evolution of brain size increased around the time the first tool was made. However, it ignores other features for complex brains such as speech. What exactly is the difference between humans and apes? The genetic journey started in 1975 by Alan Wilson and Mary Claire King, where they found that there's a 1% difference in protein sequences of humans and apes. However, proteins are made out of multiple amino acids, so that 1% is actually larger than it seems. Not only is there a difference in sequences, but there's also a difference in presence of genes. 6% of human genes are not found in chimpanzees. Also, there's a difference in number of gene copies found within both species. Different human races exist because the geographic separation was long enough to cause genetic divergence to occur. Genetically, there's no sharp difference between race and the phenotypes that derive race. All races have the same alleles but have different frequencies. Humans left Africa 60 to 100,000 years ago, leaving little time for genetic divergence to occur. Therefore, race is just a social construct. Physical differences are not a characteristic of the genome as a whole. Some differences make sense as adaptations to different environments. Skin is a good example. Dark skin in tropical groups is used for protection against harmful UV light rays. Pale skin allows light to penetrate the endothelium for vitamin D. Sexual selection is a possible driving force in the evolution of races. Cultural change can also produce a genetic change. Gene-culture coevolution is the idea that change in cultural environment leads to new types of selection on genes. Sexual selection acts fast, so it's a good candidate for driving rapid evolution and differentiation of physical traits. Another organism that shows sexual selection driving evolution is Saccharomyces cerevisiae. Sex favors recombination and the efficiency of natural selection by fixing or purging new mutations. 12 asexual species and 6 sexual species were observed over 1,000 generations. It was found that sexual species had an increased fitness, 44 de novo mutations per population, and fewer mutations were fixed in sexual populations. Sex approves efficiency of selection, so harmful mutations won't be fixated, and mutations may be beneficial for one, however, they may be the opposite or deleterious for the other. The next section of the book we'll discuss is What About How?
Jerry Coyne describes gene-culture coevolution as the idea that change in cultural environment leads to new types of selection on genes. An example of this is the enzyme lactase. In the past, if not all, human beings lost the ability to process lactose after infancy. This was because our ancestors had no source of milk, so this enzyme was not needed. However, today the enzyme lactase is now seen and carried beyond infancy. Evolution had taken place. This was because there was a change in the cultural environment as human beings began to herd cows and use milk as a rich source of energy. By DNA sequencing, it can be determined that the tolerant allele arose by mutation sometime between 3,000 to 8,000 years ago. The lactase enzyme was mainly found in populations where cows were being raised. Some people are lactose intolerant because this enzyme is turned off after infancy, but those who carry on the lactase enzyme have an advantage as they can gain rich energy from milk, while those whom don't are vulnerable. Are we still evolving? To some degree, we are de-evolving. Genes, once unfavorable, are no longer so bad. For example, bad eyesight could have meant death thousands of years ago when hunting or gathering. Now, with a pair of glasses, it's no problem, and those bad genes get passed down as glasses continue to be available. Many types of selections that challenged our ancestors no longer apply, as we have grocery stores, medical, etc. However, evolution can still be seen today. For example, in Africa, where diseases like malaria and AIDS continue to be a major factor in mortality rate, there are alleles to counter these diseases, like hemoglobin, which provides its carriers resistance against malaria. And the mutant gene, CCR5 delta 32, provides its carriers protection against infections with the AIDS virus. Selection is taking place here, and therefore evolution, although the process may be extremely slow, continues to shape the human population. We are evolving mammals, not the end product of evolution, although the genetic progress is slow. Evolution today. Luigi Russo led an experiment in which selection can be seen taking place on a molecular level. He tested 10 healthy cardiologists who are exposed to ionizing radiation and 10 individuals whom are not exposed to radiation. According to Russo's findings, it emphasizes that cardiologists can induce a profound biochemical and cellular adaptation. This means that when the body was threatened by the radiation, it enhanced antioxidant defenses, as well as increased apoptotic instruction, which could help remove damaged cells. So the cardiologists being exposed to small portions of radiation were enhancing their protection against radiation, thus providing a step towards evolutionary change when it comes to our radiation defense system. Evolution Redux. Nancy Persley is a conservative American philosopher, and her notion is that lessons of evolution will affect the ethics and history and overall family life. Percy argues that our way of life and moral values will come into question if evolution is held as an ultimate truth. People demand a reason for existence, and evolution is random and doesn't provide the stability that many rely on. Percy's notion fears that if people accept that they are just evolved mammals whom came to be randomly, there would be nothing stopping us from acting like animals. Evolution versus morals. Evolution is neither moral nor immoral. We make our own purpose, meaning, and morality. Many fear Darwinism because it connects us to our animal roots, but that doesn't make us any more barbaric. We are the only species who understand how we came to be, and we can make music, write books, and share empathy for others, and should feel proud, not fear. Natural selection bestowed us with a brain complex enough to trace down our DNA history.